Alright, so hi guys. So I was gonna make a video, or I was making a video over the problem that that we went over previously. Well, it's a continuation of the previous video that I made over the following theorems: zero factor theorem and complex conjugate theorem. By the way, if y'all hear noise in the background, it is raining, so yay. Here, so let's see, hold on guys. So we're gonna do this again. Hopefully I can do it right this time. Here we want to go ahead and look at the following zeros, and these are the zeros of the polynomial, right? And we want to keep in mind these following things, right? This is what we went over in the previous video. So if y'all want to take a look at this right quick, you can pause the video, and then you can take a look at all of this stuff. So we're gonna get started. I am gonna try and just apply the theorems, guys, and I might just go ahead and rewrite them again, just so we can really understand how this goes. I know that I'm probably over-explaining this, but I just feel like, there are some people who really need the theorem right next to the whatever step we're doing. So, here, let's see. So, we're going to go ahead and state, again, or we already stated them. So, number one, we want to look at the following zero, and this is a complex zero, guys. So notice that, so this is a complex zero, and according to complex conjugate, I'm sorry guys, hold on. Let me write it down, I'm sorry, hold on guys. Okay guys, so let me highlight this right quick. So we've established that because 1 plus 3i is a 0, then that means 1 minus 3i must also be a 0. I keep forgetting a complex 0, guys. So we know that this is true. And then what we're gonna do, we're gonna use the other theorem. So I guess this is step 1 here, and then step 2 is gonna be because so if x equals a, again we're going to use this theorem, and because if x equals a is a 0 of polynomial f of x, then x minus a is a factor, a linear factor. So if x equals 1 plus 3i, let me just, is a 0, then I'm going to say let u equal 1 plus 3i, and thus if x equals u is a 0, x minus u is a factor. I know I'm repeating myself, guys, but thus if x minus 1 plus 3i is a 0, I'm sorry, if x equals 1 plus 3i is a 0, right? then x minus the quantity 1 plus 3i must be a factor, okay, is a complex linear factor, okay. I don't really know. I think it would be linear because it has degree of 1. So we know that so far the factors of f of x are x, it's going to be x, it's going to be the quantity x minus 1 plus 3i, okay, so, and actually, similarly, let me do similarly, if x equals 1 minus 3i is a 0, I'm so sorry guys, I'm trying, then x equals x minus the quantity 1 minus 3i is a factor, is a linear factor. So far, our linear factors are excuse me, so x minus parentheses 1 plus 3i, and then number 2, x minus parentheses 1 minus 3i. So this is just to state the complex linear factors. So that is what we have so far, guys. And now what we're going to do is we're going to state our other factors. So I don't know if I stated them in the previous video. I don't think I did, because since that was just pure definition. So our real zeros are x equals, it was x equals -1 and x equals 2. So these are the real zeros, guys. So if x equals -1 is a 0, right? So if we add 1 to both sides, right? And actually, I'm sorry. We get then x plus 1 is a linear factor. A real linear factor, a real number linear factor. At least that's, you know, okay, guys. So, and then if, so that's one part, right? And then if, so I just wanna, and then if x equals, I want to say x equals 2, right, is a 0, then if we subtract 2 on both sides, we get x minus 2 equals 0. So then x minus 2 is a linear factor, is a real number linear factor. Just know, guys, that it's really the same as this theorem here. I mean, if I subtract a on both sides here, then it'll give me this. Okay, that's really what this is. It's the same thing. I know I didn't explain it that way previously, but that is really the same thing. Is a linear factor. So therefore, all in all, the linear factors, both complex and real linear factors. Let me write it down, guys. I'm sorry. Give me 1 second. So both complex and real number linear factors are number one, x. It's going to be x minus the quantity 1 plus 3i. Number 2, x minus the quantity 1 minus 3i. Number 3, x minus 2. And then number 4, x. Number 4, x plus 1. Okay. So then remember, so f of x is the product of all linear factors. Thus, f of x I'm sorry, guys. Oh my god. Will equal the quantity x minus, let me put brackets here, 1 plus 3i times x minus 1 minus 3i times, and it's going to go times, x minus 1, I'm sorry, minus 2 times x plus 1. Okay, so if you want, you can state it this way. Or you can also do the following. You can distribute the negative, okay, guys? So f of x will equal, if you think about it, this is gonna go the following way. If we distribute, guys, another way we can say this, we can say this is equal to x minus 1 minus 3i, and then this is equal to x minus 1 plus 3i, right? So we can state it this way as well, okay? So another way to say this, to state f of x in factored form, is f of x equals the quantity x minus 1 minus 3i times x minus 1 plus 3i times the quantity x minus 2 times the quantity x plus 1. And this, guys, is also yet another answer in factored form. Again, I don't want to to, make the video too long, I'm going to end it here, and then in another video, and then in the part 3 video, I will state the actual standard form of this. I'm sorry, guys, hold on. So these are two different ways to say the factored form, guys. I know this was a really long video, I'm sorry, or a pretty long video. But that is going to be it for this video, guys. Again, I will make a third part video on actually how to state this in standard form. So if anybody does have any questions, please let me know. And thank you all so much for watching, and please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys. Hi, guys. I am so sorry. I forgot one thing here. So, there is one thing I forgot here. The leading coefficient of this was -1. So, yeah, I made a mistake. Sorry about that. So, one thing I forgot to put here, I meant to say this is gonna be it's gonna be f of x equals a negative parentheses, and then this is the actual factored form. I do apologize, guys, I forgot to put that in. And also over here we have to put in a negative, so sorry about that, guys. It was gonna be it's negative parentheses. So yeah, because if y'all remember, a was -1, and that was the leading coefficient. So yeah, that was it, guys. And in the next video, we're gonna go ahead and just do the actual expanded form. But yeah, I hope that helps, and